Hi, it's Mr. Lineski here with probably your last top 5 and under 5 video. I'm calling this in roughly under 5 because let's face it, I haven't had one of these things in under 5 minutes in a very long time, but let's get started. First thing we need to know about circles here is vocabulary. So we had a lot of vocab with circles. So let's say in this diagram that the center of the circle is the point C. A diameter is any segment that goes through the center with both endpoints on the circle. A radius is a segment that goes from the center of the circle to the end of the circle somewhere. So a diameter would be AB, a radius would be CD. A chord is any segment with two endpoints on the circle that doesn't necessarily have to go through the center, so DG would be an example of a chord. A tangent line is any line that touches the circle at one point, so it touches here at F, that would be EF as a tangent. A secant is any line or array or a segment that goes through the center, it goes through the circle at 2 points, so HI would be an example of a secant. A central angle is any angle that meets where the vertex is the center of the circle, so angle ACD would be an example of a central angle. An inscribed angle is any angle where the vertex of the angle is on the circle, so AFE would be an example of an inscribed angle. A minor arc is any arc being the pieces around the outside of the circle. Minor arc would be less than 180 degrees. A major arc is something that is bigger than 180 degrees, so AFI, and remember major arcs are denoted with 3 letters, minor arcs are denoted with 2, and a semicircle is any arc that includes a diameter, so A to B equals 180 degrees. That makes it a semicircle or a half circle. Moving on with inscribed angles, we had 3 scenarios on how to solve for problems when we had inscribed angles. The big key to this is that you don't want to forget that you're always going to be doing 2 times the angle. Every situation on inside outside, it's always 2 times the angle. So for this example here, this is on the circle, the vertex of the angle is on the circle, so we're going to do 2 times the angle, and that's going to equal the arc. So if I was solving for x here, I would just do 2 times 40, and that equals 80. Inside, if the situation is inside, you need to remember that you're going to add the arcs. So for this example, it's 2 times the angle, so 2 times 100 is equal to, and then add the arcs. So 130 plus x, so that gives me 200. And then when I subtract 130 from both sides, I get x is equal to 70. When it's outside, what you want to remember to do is that you're subtracting the arcs. So it's 2 times the angle, it's always 2 times the angle, so 2x is equal to 150 minus 20, you get 2x equals 130, divide both sides by 2, and you get x is equal to 65. So those are your inscribed angle formulas to remember. Let's move on. Chord lengths. There were 2 scenarios with chord lengths. You had inside and outside. If it was inside, you did part times part equals part times part. So this example here, what I would do is I would do 6 times x, those are the 2 parts of this chord, is equal to the 2 parts of this chord, 4 times 3. 6x equals 12, divide both sides by 6, you get x is 2. Hooray, good times. Alright, outside. If you're doing outside, it's the outside part times the whole thing equals the outside part times the whole thing. So we're going to look at this chord first, so the outside part is 3. The whole thing we add together. So 3 plus x, or x plus 3, doesn't matter. And then the outside part here is 2 times the whole thing, which is 12. So now we distribute the 3, so we get 9 plus 3x is equal to 24. Subtract 9 from both sides, you get 3x is equal to 15. And then divide both sides by 3, and you get x is equal to 5. Moving on, we have the equation of a circle. So the equation of a circle, standard equation of the circle here is x minus h squared plus y minus k squared equals r squared, where x and y represent any point that is on the circle, meaning the outside of the circle, hk represents the center of the circle, and r represents the radius of the circle. So if I had an example here where I gave you this equation and asked you what's the center and what's the radius, the center here would be 5, negative 3. So remember, if the sign changes, you're doing the opposite. And then this last number here to find the radius is not 16, the radius is the square root of 16, which is 4 for that example. And then finally, we have these questions of, is it tangent? Typically, we had a triangle here, and we would ask, is BC tangent to the circle with center A? So one thing we want to do here is just Pythagorean theorem. So we're going to say 3 squared plus 4 squared equals, but what's this whole side? Remember, all radii are equal, so if this is a radius here, that's 3. Then this line here is also a radius, so that has to be 3. Therefore, we can add these together and say, well, my hypotenuse is 5. Then with Pythagorean theorem, basically what you're doing is you are just checking to see if the numbers equal each other. If the numbers equal each other, then yes, that thing is tangent. If the numbers do not equal each other, no, that thing is not tangent. Hope you've enjoyed. Thank you for watching. Good luck on your test.